Alright, this is a review of chapter 16, Parallel AC Circuits. This is the notes I print out in class. Section 16.2 is total impedance, and it's equal to the inverse of 1 over each impedance that you see here. If all of these are in parallel, like an RLC example, this is how we would draw the impedances, just with a block diagram. And you take the inverse of each one, add up the total, and then take the inverse of that total to get the total impedance. If you just do two impedances in parallel at a time, it's the same thing as resistors, Z1 times Z2 over Z1 plus Z2. This is exactly the same as resistors, both formulas. The admittance is the inverse of the impedance. And again, when the book uses that bold font, they mean the phasor. It's a phasor form, a vector. I've been using the hat over top of it, the caret, to denote that because I can't draw bold on the board or on paper. So for a resistor, it would be 1 over R with phase angle 0, which is equal to G with a phase angle of 0. Y sub R is the resistive admittance in Siemens. Z sub R is the impedance in ohms. R is the resistance in ohms. G is the conductance in Siemens. So to get Y sub L, you take the inverse of Z sub L. And for the example of an inductor, it's 1 over X sub L with an angle of 90. This is a vector here. So when you take that 1 over X sub L, which is the magnitude, and then the phase angle, putting it in the numerator, this plus 90 becomes a negative 90. So it's the opposite of impedance. B sub L is the inductive susceptance, and it's just equal to 1 over X sub L. So when we put B sub L in here, we get Y sub L equals B sub L angle of negative 90. That B sub L should be not bold, it's just a value, it's the magnitude. This is a vector and it has magnitude and direction, that's why it's bold, Y sub L. So likewise with capacitors, Y sub C is equal to 1 over Z sub C equals 1 over X sub C angle negative 90 equals 1 over X sub C angle plus 90 in the numerator. B sub C is the capacitive susceptance. It's equal to 1 over X sub C. And Y sub C equals B sub C with an angle plus 90. So to get the total admittance, you sum up all the admittances that are in parallel. And that's equal to 1 over the total impedance. If the phase angle of the admittance is greater than 0, or I'm sorry, less than 0, as you can see from here, it's negative 90, the total admittance is inductive. If it's greater than 0, the total admittance is capacitive, and if it's equal to 0, the total admittance is resistive. The equation here for the inverse of a rectangular form complex number, impedance or admittance, 1 over A1 plus or minus JB1 is equal to this. A1 divided by A squared plus B squared minus plus, which means that if it's plus here, it ends up being a minus here, JB over A squared plus B squared.